All right, all right. You guys just let me know if you can hear me or not, cause yeah, it's pretty much messed up. I didn't I didn't expect it would be this hard to kind of set things up, and it's annoying. Yeah, no, it's the first time doing it, so I kind of understand the process. And I'm just trying to figure some things out in the whole process, which is really nice as well. So yeah, if you can hear me, just like type in the chat. Let me know if you can hear me, or if you can see me as well. That would be amazing. So in the meantime, let me just get something. I'll be back. All right, cool. So I guess I'll just proceed. I Let me just share the new link with my people, so that they see what we are going to cover. So I'll just minimize that screen. Second, I need to get the link. So the link for this stream, being streaming man is difficult, but I'm getting to appreciate the process. Uh, where that thing? Where do I find? Okay, so I guess I'll have to share it with some other place, which is still okay. That's still okay. So yeah, I'll not waste much of your time. So I guess we'll just like jump right into it. And yeah, so what I normally do with these streams is I have these streams to cover this slide. So they help me understand my approach for Spring AI. So I learn during this time, and as well, just like record myself doing it. So I decided to try out live before I go live on Saturday, or I guess Saturday. I'm supposed to do a Java crash course on, yeah, because of hitting 310 subscribers, which is kind of nice. So yeah, so this session is gonna be about chat memory, advisors, and what else are we to cover? So yeah, it's chat memory, advisors, and then the prompt template. So those are the things that we're going to cover today. So let's see where we at. So we're currently prompt templates. So what I discovered from this chat client API is that it gives a summary of most of the things that you'd expect from Spring AI, and then later on um you just like do what you just like configure them, or you have a detailed explanation of how they work. Like this place here has a detailed section for prompts. Yeah, this one has a detailed section for prompts, talking about the prompt template in detail, how it works, yada yada yada, and a bunch of things that are quite important for you. And then yep, so yeah, let me just share the link again before I forget. I need to share. See, Yeah, I promise next time will be better. I promise. I'll try. I'll really try. Yeah, it's the first time doing this. And then I'll put here chat down as well. Okay. Yeah, I've shared the link. Whatever I wanted now, I guess we can proceed. Ideally, it's supposed to start at 12:30 because of the mishap. We just like got started at 30. So all right, cool. So yeah, we'll just get right into it. So in the previous session, what we did or what we covered was a bit interesting, and yeah, it's here. This is something else I was trying to add, of course, thanks to my good brother Cloud. Uh, yeah, so the previous time we met, we talked about the multi-model kind of application, and what we did is, yeah, we talked about the aspect of having a base model, and then in that base model there is a bunch of you could have other custom models from it, but the base model is still kind of the same thing. So I need to, let me just comment this one out. I need to do this. Yeah, I should have loaded these other ones. So yeah. So we talked about having a base model. So this is the configuration bit, and the beauty of it is that this repository is public, is there on GitHub. But ideally, what we're looking at is you have an application that could, you want it to perform differently, but you want to use the same base model. For this case, you're using OpenAI, and then you could configure Grok API here. So this is when you have like various functionalities within your application. You want a model that would be for fast responses, and then other one would be for code generation, and then the other one is for reasoning. So you have the same base model. You have what we call OpenAI, and then now what we currently doing is we want to use OpenAI, but we want various flavors of OpenAI kind of models. So we want a version that will help us answer fast questions. We just like want fast responses. So this one doesn't have like, it doesn't have to reason like a lot. We have another one that does code generation. So there's a bit of determinism that we want from this. It needs to be kind of accurate. And then there's a reasoning here. So the reasoning one is also needs to be kind of very deterministic with how it does the thing. So that is what we were doing. And then we have the router here. So the router is, this is something I worked on later on, but the initial implementation, we were doing things manually. But with this, I just have a router. So for this case, the router would be an LLM as well. So the LLM is the one that decides based on the user question or the whatever the user asks, we get to do we either code, reason, or we need a fast response. So, and yeah, it's quite interesting what you could do with this functionality called mutate. So this is what is doing all the magic, this mutate here. So we have a base open AI API. So when we do a .mutate, we are passing in a new URL. Of course, it's gonna be under OpenAI still. It's a flavor of OpenAI. But now for this case, we're using Grok with a Q. So Grok, it provides a bunch of OpenAI thingies that or models that you could play around with, and then you create a chat model for it. So yeah, so with Grok API, this is the Grok API. We establish it from here, and then we create a base. We create a chat model for it. And like I said, you have a base chat model, but you want a different flavor of that base chat model. So we just do a base chat.mutate like that, pass in the OpenAI API, which is Grok API with the one that we built here, and then we can now come up with the flavor that we really want from it. So this one is a Llama 3.1 instance. So this is for kind of say fast responses. And then you could also have, if you still want to use the same base model, but you don't want an external thing, for example, you could still use the mutate. So base chat model.mutate. So here you don't need to pass the Open API. So because you're not like stemming it from outside, so you're using still some flavors of OpenAI, but for this case you're going for GPT-4o. So this one is a coding model, for example. You also have a reasoning model, so you're still stemming from OpenAI, but now the difference is for a reasoning model, it's kind of trying to have a temperature that is higher. This one has a lower temperature. So a lower temperature means the model is more deterministic. Okay, I guess so, but we could Google. And then for a reasoning model, okay, this one, coding model, lower temperature, so it needs to be very accurate and whatnot. And then this one, when the temperature is high, you just have it more creative, I guess. And then finally, you create a chat client from the base model. So when you do a chat client.builder, you can pass in the model. So you create a fast model, and then this is the system prompt for it. You're a fast, concise assistant. So that's ideally what it's supposed to do. And you can see the model that you're passing for this chat client is kind of the model that we created here for the first model. So this is Llama. We got it from Grok. And then for the code client, we also have the chat client.builder. We're passing in the code model that we built, GPT 4.0. But now I guess the difference is just like the temperature that we get from it. So it's more deterministic, like I said. So we are building different chat clients, and then lastly we come create a map that would contain all these clients, and then the key for them is the model role. So we'll see how we get to use that, and then the value is whatever model. So if I come to, yeah, this is the router. If I come to router, yeah, router. So based on the user prompt, so this is, like I said, this is a new implementation of the whole thing. So if I come to this place here called classify, it returns a model role. A user asks a question, and then the first thing that happens is that question is classified. So initially what was there was I was using what? I was using a different kind of method, not using an LLM to classify. But it was a method that contained a list of things. So I'll just come here to this, say Spring AI series. Yeah. Yeah, so initially what we had was this one here. Where are you at, my boy? Oh boy. So it was somewhere. Yeah. So this is how initially the router was. So how the router was handling the things was, I had a list of code keywords and also had a reasoning keyword. So what I do is I normalize the question. So how do I classify the question? I classify, you take in the question, and then we normalize the question, you put it to lowercase. And then after checking, putting it to lowercase, we now check. So I created a method called contains any. So what it's doing is streaming the words and then checking if either of the text in the question matches whatever is in this keyword. So if it matches the code keywords, I return the role. When I say return model role.code, it returns a model that does coding, and then the other one does reasoning, and then the last one, if the default one is a model that does fast responses. Yeah, so that's the whole idea that I kind of working with. And then yeah, so this is an implementation I'm supposed to push. So this one uses an LLM as well to kind of gauge the responses or the kind of model that will be generated. So we get the classification, and then after getting the classification, we do a model roll dot value of. So it's gonna return it's either responding with a code, reasoning, or a fast one. So if it returns a fast, so we get the classification. This is the response from the model, and then we do a dot to uppercase so that we ensure whenever we do a dot value of, because it's enums, we don't get the exception. Is it illegal argument? Yeah, I guess it's the illegal argument exception when the enum that you're passing does not exist. So that's very, very important. And whenever there is an exception that is thrown, we just default to the model role that is fast. So ideally, that's what I was trying to come up with. And yeah, it was really interesting to kind of learn like a bunch of things you could do with all these things. And then you have the service here. So this is kind of not what I wanted us to cover, but it's quite important that we go through it. The smart assistant service. So as you can see, we have a map, this one here, that stores the model role and the chat client. So, and it's a bin as well. So I can reuse it easily as I want. So you can get a custom model response. So this is a record that I've created here that returns the model role, the response, and the latency that it takes to get a specific response. And yeah, so I guess that's ideally it for the previous thing that we did. So the multi-model, and you can see from the documentation, it's somewhere around here. From the documentation, yeah, this is the documentation. Yeah, you can get to see like how you could play around with multiple chat models at the same time. It's quite interesting. So can anyone try type in the chat just to ensure that we are in sync? I want to see if you guys can hear me. Just type hello or anything would help. Please type. Okay, just type, or yeah, you can do whatever. You can just type in the chat just to ensure that I'm speaking, I'm preaching to the choir. Okay, as I wait for that, I'll just continue. Need to resign this guy here. It's okay. Yeah, so today's session we're gonna cover something else. So as you can see, I was just like stealing from these things here. But something to note is when you're using Grok, I guess this one that has been provided here from Grok API is not supported currently. So if you use this one that is in the documentation, you'll definitely suffer. So you need to go for something else like I did. Thanks. If means I'm streaming in 2017, they are in 2019. Okay, so the other bit is let's see. Now what I was to cover today, I'm actually forgetting. We talked about streaming responses, we saw how one could do, and then now the other bit is prompt templates. So prompt templates lets you provide user, okay, the chat client Fluent API lets you provide user and system text as templates with variables that are replaced at runtime. So a person would do tell me the name of five movies whose soundtrack was composed by this person who is the composer. So okay, this to me seems like a map. So we're having a composer and then John Williams. So composer is the key and then the value is John Williams. So for me, this is kind of like a hash map. But I have some other notes that we could look at. But ideally, internally, the chat client uses a prompt template, a class to handle the user and the system text and replace the variables with the values provided at runtime. On a given template renderer implementation. By default, uses the string template renderer. So you can have a string template, have it separate somewhere, and then it's going to be rendered. Spring also provides no OP template. Oh yeah, this is a lot. Documentation can be tricky or hectic sometimes, but that's how we're supposed to be doing things. So if you'd rather use a different template engine, you can provide a custom implementation of the template. Okay, I'm not planning to use a different template engine, so I'll use whatever it is they provide. We see how that works. So for example, by default, template variables are identified, yada yada. Yeah, so you can create a prompt, and then this is the user. So for every user, you say you.text, tell me the names of 5 movies whose soundtrack was composed by this. So this is a different way they are doing this. So they're using this uh, brackets, and then having, okay, this is a lot. But nonetheless, I have some things here that we could use to go through it. No, okay, we'll get there. All right, so let's open the code. I'm supposed to import it. Spring AI, what's the name? Is uh, yeah, so I'm supposed to add it here. Supposed to add it as a module. Yeah, and then I refresh so that it loads all of them. Okay, so it's loaded. So what I'll do is I'll just show you. Okay, I'm supposed to come to POM as well, and then I reload all my own projects. Oh boy, still doesn't work. It's failing to import today for some very weird reason. In advisor model. Uh, okay, it's still failing to import it as a module. Ah, yeah, it's even using the wrong. Okay, so I guess what I'll do is we'll just start a new one. We'll start a new one, or we're gonna use this one here that's already provided for us. I hope this one is not okay. This one is still working, so I'll disregard the other one. Yeah, so what I'll do is we'll go to this place here. I can go to what router. Okay, okay, cool. Let's see. Okay. Yeah, my neighbor decided to become a carpenter today, so for some very weird reason. Mhm. Yeah, let's see the prompt templates. So prompts are inputs that guide the AI model to generate specific outputs. The design and phrasing of this prompt is very important. Yeah. So now let's look at it. So I guess we are set now. The prompt implements the model request. So this is kind of trying to understand how it works. But ideally, prompt is what you give the user, and okay, what the user gives is a prompt, and also the kind of there's a system prompt and there's the user prompt or messages. So there's what you define. The system restricts or guides the model on how it's supposed to behave with the user, and then the user message or the user prompt is what you as a user ask GPT, for example, or give me this and that. So that's the kind of difference that we have there. So the prompt, this is a class on its own. It's implementing the model request, and then it has a bunch of like a list of messages. So the convenience methods provide several convenience methods for accessing messages by their role. Yeah, you can access messages by their role. So we have get user message. So this returns the last user message in the prompt, or an empty user message if none exists. Get system message, like I said, this one is like the system from the system prompt. Returns the first system message in the prompt, or an empty if none. So this one I'm getting to know it today. So get last user or tool response message. So returns the last user or tool response message useful for yada yada yada. So the message is an interface that encapsulates prompts, textual content. So this is kind of, yeah, again, same thing. So it comes with the content and metadata. Uh, yeah, message extends the content. So we have the message type. So this is kind of an enum if I'm not wrong. I don't know. I guess so. Yeah, yeah. So this is the whole thing, the whole diagram that explains it. So we have the system. The message type is an enum: system, user, assistant, and tool. And then this is a message type. And then this one, we have an abstract message, text content, the message type, and metadata. And then the message, we have it there. And then the content. Okay, it's a bunch of hierarchies. Yeah, the content field, this content field here contains the textual content along with the optional metadata. That's interesting. So the roles are effectively mapped by this one, as discussed below, which is okay. And if you're new here, if you've watched the other videos that I do, this is how I learn. I just read documentation. Even in the other previous videos, I just go through the documentation. Nothing fancy, really. Yeah. So the primary roles, we have the system role, guides the AI's behavior and response style, setting parameters or rules of how the AI interprets and replies to the input. It's akin to providing instructions to the AI before. Yeah. So you tell it you're not supposed to respond to something. So I guess in the first example you did something here. Yeah, in the first example, we did something like this. So I did this demo. You are a helpful assistant that responds concisely and in plain text only. So this is kind of a simple system prompts. You see, there's a dot system. So yeah, you could do it there. And then yeah, you can tell it not to respond to. If you say here, do not answer any questions related to JavaScript. Sorry, JavaScript. Yeah. So if for example I ran this application, it won't answer like any questions that is related to JavaScript. And here you can use a string template instead of this concatenation. So I'm just doing it like that for now. But in essence, you're supposed to use a string template. So this is what is guiding the model. The user role, like I said, is represents the user input. There are question command statements to the AI. Yeah, that's okay. Assistant role, the AI's response to the user input. Assistant role. Okay, this is the AI's response to the user input. More than just an answer or reaction. It's crucial for maintaining the flow of conversation by tracking the AI's previous responses. It's assistant role messages. The system, the AI, the assistant message may contain function, tool call, request information as well. It's like a special feature in AI used when needed to perform specific functions such as calculations. Okay. So assistant role, it's the AI's response to the user's input. So tool function role is the tool function role, focuses on returning additional information in response to tool call assistant messages. Okay, so ideally tools is just like a bunch of methods or whatever that you are exposing to your LLMs. So if I want to get, for example, the weather, the current weather in where I'm at, I'd create a tool for that and then expose it to the AI, and then it can always, depending on the kind of input that I ask, it's definitely going to figure out that I'm supposed to use this tool. Just quote unquote, kind of similar to skills. So if you tell, say for example, Cloud on the terminal, I want you to generate an image. So it's gonna look on its tool set or skill set. Do I have a skill that could generate an image? And then it's gonna do the thing for you. So yeah, so roles are represented as enumeration. So we've already done this, and then this is the value. User assistant system, yeah, yada yada yada. So now on to the meat. Prompt template implements a bunch of things. But this ideally is a component for prompt templating in Spring AI's prompt template, whatever. It creates the template for you, and then it uses the template renderer API to render templates. So that are identified. Okay, the template variables are identified by the curly brace. So if you put like a curly brace for in your prompt, like we'll do in future, is we'll get to see how it does that. But you can configure the delimiters to use other syntax as well. Oh yeah, so in the other example that we saw, which was kind of funny to me, is they're using the angle brackets or those brackets. So it means you can also configure to use it, but I guess why would you do that? And we have something that is already done for us and it's easy to use. But ideally, yeah, it uses a template renderer. So by default, Spring AI is using the string template renderer, which is based on the string template, which was developed by Terence Parr. Yeah, so this is how it looks like. Um, this is kind of complex, but it looks like this. So we have a string, and then a string the template that you want to use, and then after that the other bit, so it's a function. Possibly you pass a map, string, and object the variables. So this is how it looks like. So a custom string template renderer with these angle brackets would look something like this. So prompt template, we pass it prompt template builder, and then you pass your own renderer. We're using the string template renderer. Yeah, so you see, Java is already kind of verbose, and you already want to add like a bunch of things because you want to feel so cool. This is gonna definitely mess you up. But if it's using the string template renderer, so you can pass your own delimiters, which tells me that this, when I meet these brackets or this angle brackets, it means that okay, this is uh, for example the composer, and then I'll pass map the composer to this. But this is a lot of work in all honesty, which I wouldn't want you to do it. So yeah, there's a bunch of things that happens there. So I don't know if we should go through all this, but I'm thinking we work on something that makes sense. Uh, Open that. Let's see. A simple example, prompt templates. You can pass your prompt template there. Yeah, so it just maps, man. Nothing fancy. Yeah, you are a helpful assistant. Tell me about 3 famous pirates. So this is the user text. Okay, this is for example, this is your prompt. Tell me about 3 famous pirates from the golden age of this. And then this is a message you're creating. So this is kind of a user message, because you can see here, this is a user message. And then you pass in your user text. Yeah, that's okay. And then the system text is this. So system prompt template is equals to this system text. Then the message, would create the message. So the name, your name is, you should reply to the user's request in this voice. Okay, okay, my boys, ladies and gentlemen. All right, so let's try see it in action now. I'll just come here, and then what I'll do is this. Okay, so let me just create a different class. Oops. Let's see if this thing that we opened here has an. Okay. So yeah, what I'll do is I'll come back, and then we have this one. I'll create a and then in here, what I'll do is this at this moment that I knew. Yeah. Okay, so I'd say prompt template prompt template. Of course, I need the chat client, so I can use the chat client that I already built. So I'll just say private final and say chat client. Yeah, that's the chat client. So I need to inject it. So I'll just say alt enter. I injected the chat client. Have I configured the chat client separately? Really? I think so. Okay, so I'll use the builder. Okay, so I have that. And then I can have a method. I say public string. Okay, ask a question. Yeah, ask a question. What it does is asks a question, but now I want us to configure the prompt template together. So I'll say, I guess we're supposed to use the prompt template. Prompt template. Yeah. Equals to. So let's see how they're doing it. Oh boy. Where was that? Prompt template, builder, and then I don't pass my own. Yeah, I don't want to pass my own. So I'll just say prompt template builder, and then here I'll say dot the template. So I need to pass the template here. So this is the string template. Like that. So here I'll use the string builder. Something like that. Then I'll pass the template. Then I do a dot. I don't need a renderer. I don't need a resource. Okay, you can extract it in a resource, and by this is you have I'll show you how to do that basically. Yeah, there's this, and then so what I'm supposed to do is at the end of this thing is let's see. So we build, and then we create a prompt from that template. Okay, so we'll use this one. We'll use this like this here. So what did I do here? I need this here. So tell me the name of 5 movies whose soundtrack are composed by A. Okay, composer. I don't want to use this one, so I'll use the default one. Uh, so I'll say the artist there. So this is this. And then I build the prompt template, and then now I'll extract the prompt from it. Am I supposed to use prompt? Yeah, I guess so. So I'll say string prompt equals to prompt template. Oh, is it get template? No, prompt template dot render. Yeah. Yeah, dot render. So let's see what this render method does. So there is a very nice documentation here. Yeah, extracts the key and value. So it processes, puts them, and then applies, and then it returns a string. So this dot template and processed values. Okay, the template and the processed. Okay, it's about so we are at, and that's ideally our prompt. So what I'll do next is I'll just come to this place here, and then I'll say return something like that, the prompt, and then the client. Okay, this is kind of weird. Something is not adding up. Yeah, I did the wrong thing, in all honesty. Let's see. Oh boy. So I'll go for assistance. I just want to see how it is done. Yeah. Prompt template, pass in the template, and then get the prompt. No. Uh, hmm. Oh boy, he's using chat model. You are helpful. So this is a system text. And then we create a system prompt. Okay, here it's saying you're a helpful AI assistant that helps people with information about cities. You help. Uh, okay, this is the user text. Okay, so let's see how it works. So you can have both. You can have the user and this other one. So let's see how it works. Yeah, I guess that's ideally it. Passing the template, and then you can render it, and then that's the, which is kind of weird to me, in all honesty. Yeah, that's kind of what. Because I'm just trying to think what they actually mean. If I say, if I pass the string here, if I say something like this, what will the user pass? So that's kind of weird. For me, that's kind of weird, yeah. So let me just go to this shared client API and then see the example thing. Prompt templates. Mm. So for me, it doesn't really make sense to have the question, because the user here, just like this is supposed to be what the user is asking. Maybe I could uh it only makes sense to use the system prompt as the one that uses like the string template. Okay, which is so weird. Oh boy. Let's see how this other application. Okay, so what I'll do is I'll go to GPT. Let's ask GPT and see what it says. Yeah. Hi. I am learning about. I am learning about string. Okay, not string. Prompt templates in Spring AI. I am confused I know it looks like a very fundamental thing, but it's just like gotten my attention. Like, oh crap, I am confused on which context it's best fits. So actually, is it context? So system message or user message. Uh, okay. Does it best suit show demo? Okay, so just need to stop this. Where exactly should it live? So the fog rolls like morning mist of Nairobi. Okay. Yeah. From templates fit best in the user message most of the time. System message is behavior rules. That's okay. User message is dynamic. So yeah, yeah, makes sense. Makes sense. And then when to use each one, the system message, I need code, my guy. Explain the concept of topic. Provide a simple explanation, a real world analogy, and a short example. Okay, I see what you're doing, man. I want a fully working thing. So yeah, I see what you're doing. I need a sample demo. I need a sample demo with user. Okay, let me just take this method that I have here. With this, yeah. What am I doing wrong here? Uh, okay, what am I doing wrong here? So you're rendering without providing the artist variable, and then you completely ignore prompt. So you send the question. Yeah, okay, I know that one I know where I send the question, which is wrong. So how I'm supposed to do is so this is a places where we have an issue. So we ask the question, yes, and then tell me the names of 5 movies whose soundtrack was composed by artist, and then you prompt, and then you render map.of artist question. Oh, okay, okay, I see, I see, I see, I see, I see. Then say map dot of, and then the key is the artist, and then the thing here is the question. Yeah, and then I'm supposed to pass in the prompt. Okay. Yeah, and then so become tell me the names of 5 movies whose soundtrack was composed by Hans Zimmer. Yeah, even better version of more Spring AI that is more idiomatic. I guess this is outside. It's beyond. So it's a cleaner one would be this one, not text. Okay. So my question is, what if the user wants to ask a question side stuff related to the artist or that one. Uh, okay, so here it looks funny. Most flexible, the clearest general pattern. You're a helpful assistant. This is the system you provided. Yeah. That's about right. Now it makes sense. It makes sense. So yeah, there are a bunch of ways you could customize this string template. I mean prompt template and use it wherever. So it's kind of big, bigger than I thought. I thought I'd cover everything in a single session, but it doesn't seem like it. But yeah, I get now the concept of how it does the things and whatnot. So yeah, so we render that. That has been done. And then what else? What else can we look at? Okay, there's this one as well. This one here. You have the user message. I think I talked about this one. You can also have. Oh, okay, I see. So let's try that version. Uh, so what I'll do is I'll delete this. I'll say string. I will not delete them. I can I can rename this to user message. I'll pass in the user so I can check here message. Where is spring here? Uh, goes to new user message. Yeah, that's about it. And then I can pass in the message, the user message like that. But I'm just trying to wonder where I'd possibly use something like this. User message. I need to access it. And then afterwards, this is the user message. I can have the system one. So I'll just copy that. I can have the system. So this one I just press tabs like, and then yeah, I can have the system text message. This is supposed to be the system message. It looks something like that. And then what? Like I'm having a message from. Okay, I pass in those ones, and then I can create a system prompt. Yeah, so ideally you can do this. You can also do this. You pass a system text and then you can create a system prompt from it. You say I dot create message. So where do we map things? We map the name. So map dot of name. You pass the name, and then voice is whatever voice would be passed in the process. And then what else? What else are we missing? So the question really will be, where is this name coming from as a variable? And where is this voice coming from as a variable being reused there? Man, documentation can be daunting. It can be daunting, in all honesty. But ideally, you get the idea of prompt templates. So the next possible thing that we'll possibly introduce and then move to the other thing is what we call. I'll just do an overview for it. Is POJO. Is this one? Where is Excalibur? Is the advisors and chat memory. So we have the concept of advisors. First, chat memory. Chat memory is LLMs are stateless by nature. At least when you try to use them, they are kind of stateless. So if you look at chat memory documentation here, that's the kind of first thing you see. So large language models are stateless, meaning they do not retain information about the previous interaction. So I tell it my name is Ian. The next time I ask it about anything, it's gonna tell me it doesn't know me. So this is can be a limitation when you want to maintain context or state across multiple interactions. And yeah, so there's the chat memory abstraction that allows you to implement various types of memory to support different use cases. And then the underlying storage of the messages is handled by the chat memory repository. So it's just kind of following the architecture that Spring uses. So we have the chat memory, which is the abstraction, and then the underlying storage. So you have user and then user repository. So we have chat memory repository, whose sole responsibility is to store and retrieve the messages. So it means that you can perform post and get for your messages. And then yeah, chat memory, the information that a large language model retains and uses to maintain contextual awareness. So this is just like a model, whatever the LLM is storing, and then the history is now retrieving the messages. So with this, with chat memory, you need the chat memory. So you could auto configure it wherever way. But we normally have the in memory, which is the default one to store messages in memory. And then there's the message chat window memory, yeah, to manage the conversation history. So you want this, there's concept of sliding window somewhere here. So there's a window of messages. So you can specify that a specific chat can store like 30 messages only. And then if it's full, you say the context is full or something of the sort. So you don't need to restart a new conversation. And then you can also have a different repository. So we have the in-memory chat repository. We also have like the Cassandra, JDBC, Neo4j, etc. But this is the mother of, this is the starting point for all this. So the memory types, we've said, we have the message window chat memory. So this maintains a window of messages up to a specified maximum size. And then when the number of messages exceeds the maximum, the older messages are removed while preserving system messages. So only the system messages are retained. So the default DAO window size is 20 messages. So this is how you create the message window chat memory. And then Spring AI offers chat memory. So now this is now the memory storage. So how do we store? So we have the in-memory chat memory. All of them stem from the chat memory repository. So this is the interface that you provided with, and then you can provide your own specification. So do you want to do in memory, or do you want to do JDBC? JDBC, you can use JDBC as a storage point for whatever. So yeah, this is the inbuilt one that JDBC uses. So how do you create that? So you need to add the dependency for that. And you can see we are currently on version 1.1.5. So there's this starter. And then after that, you can configure your memory there in whatever manner. So I guess in the next possible session, if we stream again, is we going to talk about now the memory, or I need to do a separate recording of memory? But ideally, it just enables you to store the messages. And you can see, you can say chat memory repository, yada yada yada, and then you say JDBC chat memory repository, create a builder for it, pass the template that you've created for JDBC, and then you can pass in the dialect. I don't know if this is still compulsory, and then yeah, you can reuse it there, and then you create a maximum of messages that you can hold. But ideally, that's those are the things you need to have an understanding of when it comes to all these things in memory. You can play around with either. I've only played around with JDBC. I've not tried Cassandra or Neo4j, but it's possible to use it. A good repository. So we were using GPT here. So I'll just say, yeah, Dashan is having some things here. So okay. Who has been pushing. Yeah. Rag source main java config vector store. This is a vector store. I don't know if he has some place where he's configured the memory. No. So let me see. and I can see it now. Let's check my stories. Just Spring AI workshop. As you can see, I stole the architecture which Dashan was using. I don't need this one. I need this one. Config, memory config. Yeah, as you can see, we have the memory here. So we have the chat memory. And then this one, the first one was I was using an in-memory chat. This one here. And then the other one, we require the Spring Starter for JDBC, which is fantastic. So as you can see, you can create either. So you can pass in a JDBC template, and yeah, off you go. It configures it, and yeah, yeah. So that's ideally it. How you look at them, but I guess we'll have to do a separate session for this, where we kind of do a deep dive. I'll clean up this code. It's a bit messy. There are things I need to go figure out as well. But yeah, I'll go clean this up. I'll come up with a cleaner thing, and then the repository should be this, where you get to see the code. The code will be published somewhere, yeah, somewhere here. Repositories, a Spring AI series, yeah. So the code will be published here. So I'll come up with a structured thing that will enable you have a clear context or clear understanding of these things. So yeah, this was not the best stream, at least I'd say. Yeah, it was nice. It was nice. But there were a couple of mishaps which brought about confusion. My OBS refused to work at the end when I needed it the most, but nonetheless, thanks for the viewers who've been there. Yeah, I promise next would be better. I'll definitely improve on this, and yeah, kind of try make something better, all of us. But if you missed anything, you should not forget that LLMs are stateless, and you need to inject memory in them for you to for them to remember who you are at least. And for prompt templates, I'll work on something cleaner, explains it in details and how to use it and how to configure it. But yeah, thanks for tuning up to this point. Hope you guys have a lovely day ahead. Thanks for watching. Bye.